What about the worlds lost in the darkness between stars? Today we're exploring planets drifting alone through space, worlds stripped of their atmospheres and the cosmic orphans of our galaxy. Let's venture into the dark. First up, let's talk about the ultimate cosmic loners, rogue planets. These are worlds that don't orbit a star. They're untethered, drifting through the vast, cold emptiness of interstellar space. Imagine a planet like Jupiter or even Earth, but without a sun to warm it. That's a rogue planet. So, how does a planet go rogue? Well, there are a couple of theories. The most common one is that they're ejected from their home solar systems. Picture this: a young, chaotic solar system with planets jostling for position. A gravitational tug-of-war between massive planets can send a smaller one flying out into the galaxy like a cosmic slingshot. For a long time, these rogue planets were just a theory. How do you find a dark, cold planet in the vastness of space? It's like trying to find a needle in a haystack if the haystack was the size of the Milky Way and the needle was invisible. But astronomers are clever. They use a technique called gravitational microlensing. It's a bit like using a cosmic magnifying glass. When a rogue planet passes in front of a distant star, its gravity bends the light from that star, causing it to brighten for a short period. It's a fleeting event, a tiny blip in the data, but it tells us that something massive just passed by. And we're not just talking about a few of these wanderers. A recent survey led by Dr. Nuria Muret-Roig found at least 70 new rogue planets in a nearby star-forming region. That's the largest group ever discovered, and some scientists, like Hervé Bouy, an astronomer at the Laboratoire d'Astrophysique de Bordeaux, believe there could be billions of these free-floating planets in our galaxy. And it gets even more exciting. NASA's upcoming Nancy Grace Roman Space Telescope, set to launch in 2027, is expected to be a rogue planet-hunting machine. It's predicted to find around 400 Earth-mass rogue planets. That's a huge leap in our understanding of these lost worlds. So, what would it be like on one of these rogue planets? Cold, dark, but maybe not entirely lifeless. Some scientists speculate that if a rogue planet is large enough, its core could stay molten for billions of years, providing a source of geothermal energy. And if it has a thick atmosphere and a subsurface ocean, like Jupiter's moon Europa, it's possible that life could exist in those dark, hidden waters. It's a tantalizing thought, isn't it? A world that doesn't need a star to have the potential for life, a true lost world harboring its secrets in the dark. Not all lost worlds are born that way. Some start out with all the right ingredients for life, only to have their paradise stolen from them. These are the fallen worlds, planets that were once habitable, but have been rendered barren by the very stars that were supposed to give them life. And our closest exoplanet neighbor, Proxima Centauri b, might be one of them. Proxima b is an Earth-sized planet in the habitable zone of its star, Proxima Centauri. That means it's at the right distance for liquid water to exist on its surface. For a while, it was one of our best candidates for a nearby habitable world. But there's a dark side to this story. Proxima Centauri is a red dwarf star, and red dwarfs are known for being a bit temperamental. They can unleash incredibly powerful flares, blasting their planets with intense radiation. In fact, Proxima Centauri bombards Proxima b with hundreds of times more extreme ultraviolet radiation than Earth gets from the sun. So, what does this mean for Proxima b's atmosphere? Well, it's not good. NASA scientists ran a simulation and the results were grim. They found that Proxima b's atmosphere could be stripped away 10,000 times faster than Earth's. In fact, it could have lost its entire atmosphere in just 100 million years. That's a blink of an eye in cosmic terms. Without an atmosphere, a planet is left naked and vulnerable. There's no air to breathe, no protection from harmful radiation, and no way to regulate temperature. Any water on the surface would either boil away or freeze solid. Proxima b, once a beacon of hope in our search for life, may be a dead, barren world. And this isn't just a problem for Proxima b. Many exoplanets we've discovered orbit red dwarf stars simply because they're the most common type of star in our galaxy. But this discovery makes us question the habitability of all of them. We're also seeing evidence of this atmospheric stripping in action. Astronomers have found a class of exoplanets that are shrinking. These are planets that are losing their atmospheres and getting smaller over time. It's a stark reminder that even if a planet is in the right place, it doesn't mean it's safe. These fallen worlds are a cautionary tale. They show us that habitability is a fragile thing and that the universe can be a harsh and unforgiving place. A planet's paradise can be lost in an instant, leaving behind nothing but a dead, silent world. And finally, we come to the most mysterious lost worlds of all, the ones we can never know. The ones that are so far away, so hidden in the dark, that we may never even be able to detect them. Think about it. We've only been searching for exoplanets for a few decades. We've found thousands, but that's just a tiny fraction of what's out there. The Milky Way is vast, and there are countless worlds that we'll never see. And what about the worlds that have come and gone, the planets that formed around stars that have long since died, the civilizations that may have risen and fallen, leaving behind nothing but ruins on a dead world lost in the dark? These are the ghosts of the cosmos, the stories that we'll never get to hear. It's a humbling thought and a little bit sad. But it's also what makes astronomy so exciting. There's always more to discover, always another mystery to solve. So the next time you look up at the night sky, don't just look at the stars, look at the darkness in between, because that's where the lost worlds are. The wanderers, the fallen, and the ghosts, they're a part of our universe too, and they have stories to tell, even if we can't always hear them. Now, you might be wondering, how exactly do we find these lost worlds? It's one thing to talk about planets floating in the darkness, but it's another thing entirely to actually detect them. Let me walk you through the incredible techniques astronomers use to hunt for the unhuntable. For rogue planets, the primary method is gravitational microlensing, which I mentioned earlier. But let's dive deeper into how this cosmic detective work actually happens. Imagine you're looking at a distant star through a telescope. Suddenly that star gets brighter for a few hours or days, then returns to normal. What just happened? A massive object, potentially a rogue planet, passed between you and that star, acting like a natural magnifying glass. The beauty of microlensing is that it doesn't require the planet to emit any light of its own. We're literally using Einstein's theory of general relativity to detect these dark worlds. The more massive the object, the stronger the lensing effect. And here's the really cool part. The duration and shape of the brightness curve tells us about the mass and distance of the lensing object. But here's the catch: microlensing events are incredibly rare and they only happen once. You can't go back and observe the same event again. It's like trying to catch lightning in a bottle. That's why projects like OGLE, the Optical Gravitational Lensing Experiment, monitor millions of stars simultaneously, waiting for these fleeting cosmic alignments. For the young rogue planets that Dr. Mira Roig's team discovered, they used a different approach entirely. These planets are still hot from their formation, glowing faintly in infrared light. It's like finding embers in a dark forest. They're not bright, but they're warm enough to detect with sensitive infrared cameras. The team analyzed 80,000 images taken over 20 years from telescopes around the world. They had to carefully track the motion of these objects across the sky, measuring their colors and brightness to distinguish them from background stars and other celestial objects. It's painstaking work that requires incredible precision and patience. And then there's the upcoming Nancy Grace Roman Space Telescope, which is going to revolutionize our understanding of rogue planets. Roman will conduct the most comprehensive micro-lensing survey ever attempted. From its vantage point in space, free from atmospheric interference, it will be able to detect much smaller and more distant rogue planets than we can from Earth. The telescope will monitor hundreds of millions of stars in the direction of our galaxy's center, where stars are densely packed. This increases the chances of catching micro-lensing events. Roman is expected to find not just the massive Jupiter-like rogues, but also Earth-sized wanderers that have been nearly impossible to detect until now. But detecting atmospheric loss on distant exoplanets like Proxima b presents its own challenges. We can't directly image these planets, they're too far away and too close to their bright host stars. Instead, astronomers use computer models and simulations like the one NASA used to study Proxima b's fate. These models take into account the star's radiation output, the planet's magnetic field strength, atmospheric composition, and orbital distance. They simulate thousands of years of stellar bombardment in just hours of computer time. It's like running a cosmic experiment in fast forward to see how the story ends. Let's talk numbers for a moment, because the scale of lost worlds in our galaxy is absolutely mind-blowing. Remember when I mentioned that NASA scientist David Bennett estimated there are 20 times more rogue planets than stars in our galaxy? Let's put that in perspective. Our Milky Way contains roughly 100 to 400 billion stars. If Bennett's estimate is correct, that means there could be anywhere from 2 to 8 trillion rogue planets drifting through our galaxy. Trillion, with a T. That's more rogue planets than there are trees on Earth by a factor of thousands. And these aren't just theoretical numbers. The recent discoveries are backing up these predictions. The Mire-Ruag survey found 70 to 170 rogue planets in just one small region of space, a star-forming area that's only a few hundred light-years across. If that density is representative of the entire galaxy, we're looking at an absolutely staggering population of wandering worlds. But here's what's really fascinating: the size distribution. The research suggests that smaller rogue planets are more common than larger ones. This makes sense from a physics standpoint. Lighter planets are easier to eject from their home systems during gravitational interactions. It's like a cosmic game of billiards where the smaller balls get knocked off the table more easily. For atmospheric loss, the numbers are equally sobering. The NASA study on Proxima b showed that the planet could lose its entire atmosphere in anywhere from 100 million to 2 billion years, depending on various factors like magnetic field strength and atmospheric composition. To put that in context, Earth has maintained its atmosphere for over 4 billion years. Proxima b's atmosphere, if it ever had one, might have been gone before complex life even appeared on Earth, and Proxima b isn't unique. Red dwarf stars make up about 75% of all stars in our galaxy. Many of the potentially habitable exoplanets we've discovered orbit these temperamental stars. If atmospheric stripping is as common as the models suggest, a significant fraction of potentially habitable worlds might actually be barren, airless rocks. The implications are staggering. We might be living in a galaxy where the majority of planets are either wandering alone in the dark or have been stripped of their life-giving atmospheres. It's a sobering thought that challenges our assumptions about how common habitable worlds might be. But here's the exciting part, we're just getting started. The next decade is going to be absolutely revolutionary for our understanding of lost worlds. The Nancy Grace Roman Space Telescope is just the beginning. Roman will work in tandem with ground-based telescopes like Japan's Prime telescope in South Africa. Prime will conduct the first wide-area microlensing survey in near-infrared light, using detectors developed for Roman. This collaboration between space and ground-based observations will allow us to measure the masses of rogue planets much more accurately than ever before. And then there's the James Webb Space Telescope, which is already revolutionizing astronomy. While Webb isn't specifically designed to hunt for rogue planets, its incredible infrared sensitivity could potentially detect the faint heat signatures of nearby rogue worlds. Imagine being able to study the atmospheric composition of a planet that doesn't even orbit a star. The European Space Agency's Euclid mission, launched in 2023, will also contribute to rogue planet science. While its primary mission is to study dark matter and dark energy, its wide-field surveys will likely catch micro-lensing events as a bonus. Every new set of eyes on the sky increases our chances of finding these elusive worlds. Looking even further ahead, proposed missions like the Habitable Exoplanet Observatory, HABEX, and the Large UV/Optical/IR Surveyor, LUVOIR, could potentially image rogue planets directly. These next-generation telescopes would have the sensitivity and resolution to detect the faint infrared glow of rogue planets, especially the larger, younger ones that are still cooling from their formation. But perhaps the most exciting possibility is what we might find on these lost worlds. Advanced telescopes could potentially detect the spectral signatures of atmospheres around rogue planets or even the chemical signs of subsurface oceans. Imagine discovering that some of these wandering worlds harbor life in their hidden depths. The study of atmospheric loss is also entering a new era. The James Webb Space Telescope can directly observe atmospheric escape in action around some exoplanets. We're moving from computer models to real-time observations of worlds losing their atmospheres. This will help us understand which planets can hold on to their air and which are doomed to become barren. And as our detection methods improve, we'll be able to find smaller and more distant lost worlds. The ultimate goal is to create a complete census of our galaxy's planetary population. Not just the worlds that orbit stars, but all the orphans, wanderers, and fallen worlds that make up the true diversity of planetary systems. These discoveries will fundamentally change how we think about planets and life in the universe. We're learning that planetary systems are far more dynamic and chaotic than we once imagined. Worlds can be born, live, die, and be reborn in ways we're only beginning to understand. The lost worlds in the dark are teaching us that the universe is full of stories we never expected to find. Thanks for joining me on this journey into the dark. If you enjoyed this video, be sure to like and subscribe for more cosmic adventures. And let me know in the comments below what you think about these lost worlds. Do you think life could exist on a rogue planet? Let's talk about it. Until next time, keep looking up.